Hello everyone and welcome to my YouTube channel. If you're new here, I am Vijay and I make videos around AI and LLMs. So if this is something that interests you, then do consider subscribing to my channel. With that, let's dive into the video. So this is an ongoing playlist where we are working on the text-to-SQL project, and this video we'll just continue working on it, right? So in the previous video we looked at some ways of improving our version v5 of our app. We highlighted different areas. From this video and henceforth, what we'll do is we'll try and focus on each of this areas that we identified earlier, right? So I encourage you to follow along the previous videos as well, especially the last one where I've highlighted and actually gone in depth discussing each of them. Today what we'll do is we'll discuss at this one specific uh, optimization, right? And that is to build test questions and ground truth data sets. So why is this important? This is because we highlighted earlier that there are several improvements that can be made to the app throughout, right? And the thing is, how do we know that the app is improving or depreciating with each of the changes? Now, sure, there are some clear metrics like token usage or the latency or the quality of the answers, or if the app is breaking in between or no, and so on, right? But let's say the app is working fine, right? How do we know that it's actually answering the questions right? Now maybe I've changed a prompt in between, or I've changed or added a node in between. Now how do I know that if adding or making any such changes is actually resulting in an improvement in the model, or at least worst case it should remain the same, right? It should be able to answer your SQL questions irrespective of what changes here it's going through here. um, so that's why we have to build a set of questions, and also have ground truth answers for it, and then we can base our model improvements based on them, right? So what I did was I sort of worked on it and came up with these 16 17 questions. Now of course this has to undergo its own set of iterations. These are just some of the areas that I've tried to cover. So what I did was I've grouped them into certain categories, and we have the questions and the ground truth answers. I've tried my best um, so I validated these answers, so it's pretty much accurate. And have some basic questions here. You can see show me all the customers and where they live, give me the list of all orders and where they are placed for each seller, calculate the running total of items sold, and so on, right? And in terms of category, I have some basic retrieval questions, so these are straightforward questions. Some filters, so you can see the filter over here is that the date has a filter here, here the state has a filter. So these are some simple filters. And then you have joins, so these are simply joining one table, right? So you have more than one table where the data has to be retrieved from. Multiple table is when you have more than one table to be joined. And some aggregations, so these are basically sum or some sort of count. You have aggregation with filter, so a combination of these two. And some complex questions, right? So these might include multiple joins, multiple filters, group bys, and all of them together. So like I said, this is just like a base set of questions that I came up with, and you have the answers here. And the way we evaluate this is using this tool called LangSmith, and this is something that integrates very well with LangGraph and LangChain. So that's why we're going to be using this. I also have some videos uploaded on my channel, in terms of basically explaining how to create data sets, how to use the LangGraph platform. So this is it basically, how to use the platform to create evaluators, run experiments, and so on. So I encourage you to take a quick look through, I think there are like 3-4 videos there. I encourage you to have a look on them, so you understand how we can work with it. In this video, I assume that you already know how to work with LangSmith, so I'm just going to run through the different steps without going in depth or explaining how it works. So what we do is we go into this evaluation section under datasets and experiments, and the first thing that you have to do is go here and upload your dataset, right? So you can start from scratch or create from a file, and what you basically do here is to pull out this data set. You can give it some name, some description, your input fields and the output fields, right? So my input field, so if you remember, we had 4 fields there. My input field is the question, output field is the ground truth, and metadata fields is any other sort of information that you might want to store. In my case, I want to store the category details that will help me filter or group by later on, and we'll see that. And yeah, pretty much you can go ahead and create the data set, right? So I've done it already. I have the text-to-SQL data set here, basically the examples. So I have all the 17 questions loaded here. You have the inputs, reference outputs, and the category. One thing we can do here is to split these data sets. By default, all these data sets are base, but okay, wait, let's display all of them. But what I also did was to group, let's say, these basic retrieval questions into something called as quick test. Right, so these are simple SQL questions. So when I'm evaluating these, right, maybe I just want to run a quick test on them and ensure that, hey, my connection between the LangSmith and my working model is fine. So it helps me to quickly run the test on just these 2 examples instead of the whole. One more thing that we can do, like, let's go ahead and create one more split. What I'll do is I'll create a split on the complex logic ones. I think I had 5 questions there. I can select all this, add them to split, create new split, and call them uh, golden set, right? Wait, did I misspell it? Right? No, that's fine. Right. Um, right. Now you can see that the tag has been added here. Now the idea behind this is maybe sometimes I just want to run a single test and ensure that, hey, my model is working fine. And instead of running the model, the test on all the 17 questions, maybe I just want to run on these complex ones. So if they're working fine on complex, maybe I can be confident that it's going to be fine with the other ones too. So just a way to filter, right? But yeah, once we have the data set ready, the next step is to build evaluators. So these are the sort of metrics upon which the data set is evaluated, right? That's how probably you can put it into the simplest definition. There are different ones. Now, for our use case, it's going to be a code-based reviewer, right? Let's see. There is something called as a code checker, and we are using LLM as a judge. So the output, so we have the reference output, right? And when we run each of this test, we'll have a actual like a model output for this. It can be right, it can be wrong, it can be partially right, partially wrong, and so on. So an LLM sits at the junction and reviews the reference output and the actual output that comes from our version v5, and it checks them, right, evaluates them. And if you ask me on what basis, let's go into this. By default, there is some rubric given here, some instructions guide on how it should evaluate and how it should penalize and so on. You can put in your input variables. In our case, it's the question, and output variable is your ground truth, right? And if you come here, you can see that the response is boolean. So if it, based on these instructions, if it believes that the answer is right, it gives 1, if not 0. So you build this evaluator. I have done it already. So if you go into evaluators, you can see that LLM as a judge is created as the evaluator here. So that's it, right? We have the examples, we have the evaluator metric set. The next thing is to run experiments. I have done some experiments, test ones, but of course we'll go into detail about how to set these up. Not into detail as such, I've covered it in the previous video, but yeah, in this use case, let's see how we do it, right? So what I did with the version v5 was, one change that I made was that after our workflow, so this is where we define the nodes, edges for LangGraph. And for testing this workflow, here earlier we were testing it within the same file. But right now what I've done is I've commented this out, but yeah, just leaving it here for a future reference. But what I did was I moved it into a function, basically wrapping it inside a function. What this takes is a question, right? And in the initial state, basically all the set of variables, same variables, the user query is the question that is passed on here, right? And this workflow is invoked using this initial state. All the others are blank because in the earlier video we saw that each of this intermediate states get updated. Each node accesses at different stages and updates it at different point. This SQL query gets updated at the final stage, and that's going to be our answer. So this is what is returning. So basically this thing is required because for the evaluation we pass the function to the evaluator. It evaluates it and we want one single final answer with a specific heading. Yeah, so this is what I did with this is the change that I made in the version v5. And what I did was I added a test eval Python file. So I'm importing the function from v5, and I'm also basically calling this function, right, from LangSmith. And this is something that you go here, run your experiment, run in SDK, and here you have all the details. Basically this is what you install the dependencies, set up these API keys. This has already been set up initially, and then you go about defining the dataset name. This is something that we already defined, and so it's pulling it on its own. And then you define the evaluate metric. In this case we provide the function name, which is the run text-to-SQL. You provide the dataset name. So in our case we can ideally have multiple datasets, right? So we go here, I have multiple datasets here. The one that I'm interested in is the text-to-SQL dataset. So that's what I have provided here. Some prefix for the experiment, and the number of repetitions I want to provide here is 2. This is because LLMs can provide different answers in different runs, right? So I just want to give it more than one turn for it to give me a more confident answer. It's possible that maybe one time it fails but the next time it's able to provide right answer, or maybe one time it provides a partially right and maybe next time it provides an even confident answer. So we'll see later in LangSmith when this is run and how this is helpful. But for time being, we are running 2 repetitions of eval. So basically each question is evaluated twice, and maximum concurrency I've put it to 2. So it just speeds up the parallel processing. And yeah, that's pretty much it. And let's now run the let's run this file. It is going to take a while, so I'm going to pause it in a while, but let's see what this has to show, right? So yeah, it provides a link for you to directly go into the page and sort of follow the experiment. And here if you can see, it's on the 3rd iteration now. We have 17 questions and each of it is running twice. So ideally this should show 34. I'm going to take a quick pause. or let's actually do one thing. This is going to take a while. What I'll do is I'll quickly jump to LangSmith and show you the process, right? This is still in process, which is why you don't see a lot of these details populated here. It's on run 13 at the moment. Uh, if you see the second question, second experiment, it was basically the same, and you can see how there were 34 runs here and some other details. We can go over here, but LangSmith is a really good tool for this such evaluations. You can see how we can compare. So this is for tokens. So the kind of token usage between the second run and the third experiment. Of course, this is not completed, so this will also boost up to close to this. The error rate is tagged. You can also sort of filter based on the models that you have used. Right, so maybe you're trying different models. So when I say models, the underlying OpenAI or any other LLM, right? So you can test upon those and so on. It just gives you more flexibility in terms of analyzing and comparing. But yeah, let's go back to this. As you can see, the run is completed. There are 34 iterations here. It's taken quite a while. Now coming back to this, of course, you can see the test has been completed, but it's not exactly completed. It's still happening. So what's happened so far? Um, oh yeah. So what generally happens is it runs the questions. So for each input, you have the respective outputs. So it's run each of them twice, so 34 runs. And after it has run, right, what happens is it compares these two. So there's an LLM sitting and compares these two. So that's like an additional set of step that happens for each of them. I think it's completed. So at times it doesn't populate completely, but yeah. Right, so you can see the kind of comparison between the two runs. It's pretty much the same. I didn't change here, so it's just how it has run this time. But if you are making any significant change between these two runs, then it becomes a good comparison point for you to decide upon them, right? But yeah, let's go into the third experiment. You can already see that some of them have failed, some of them show green, gray, and so on. We'll go into detail. One thing that I want to do here is to group by the category. We had put it as a metadata in between, right, while loading the data set. So if I load it by category, I can sort of group them based on the kind of experiments and see where exactly it has gone right or failed. It looks mixed for me at the moment, but let's see. So for the aggregation category, right, both of them have failed. Let's look at one question. If you look here, the question was show the total freight charged by each seller. This is the ground truth I'm expecting. If you look at the linked runs, there should be two because we ran each experiment twice. Yeah, okay, there are four here because of course I ran them a couple of times earlier. But these are the two runs. We can look at the time, right? So these are the two that ran now. Yeah, so these are the two runs, and if you go into this, you can look at the specific outputs at each stage and so on, right? This is how you evaluate on your own and look at the individual steps. So that's that. But if we look at this specific output, right, you can see that the first run, if we look at the trace, this shows the, oops, right, so yeah, so this shows us the exact output in comparison to the reference output. Let's quickly have a look, right? Looks good to me, but of course it has failed. But so let's see. Uh, if we look at the scoring for the rep 1, it was 0. For rep 2, again it was 0. But now if we go into these details, it will explain how the evaluator sort of evaluated this run. And if you remember from our evaluator the LLM as a judge when we added it. We had given it some rubric. Now I left it as default at the time, so yeah. Uh, so we can of course go through this, but the conclusion is that because the query omits sellers with no order items, it does not fully satisfy the requirements. In all cases, the score should be false. I think I've seen this already. The main issue here is in terms of joining. It does not do a left join. I think the example that I provided itself was quite wrong. It should have been a left join. And also it suggests that we should coalesce to avoid any null values and so on. So yeah, apart from our reference output, right, it is also sort of evaluated based on the rubric that we have provided. Yeah, so that was about it. Let's look at a different example here. Right now, for aggregation with filter, this shows 1. So what this means is that both the evaluations have run successfully, and if you go into any eval here, yeah, so of course this has its own way of evaluating. Let's see, is there a conclusion here? The SQL is entirely correct, and will return the orders with at least 15 items, so the score should be this. So of course it can be a sort of gray in between, in the sense that, hey, maybe there are certain improvements, but overall it should follow our rubric and should give us the right answer. So in that way this was marked as success. Let's look at some of these gray ones. If we look here, uh, so this shows that rep 1 was 0 and rep 2 was 1. So that's why it has an average score of 0.5. So let's look at why this failed. And this is a basic retrieval, so I'm quite surprised why it's failed even a basic one. Let's quickly look at the conclusion. Okay, what's the question? Show me all the customers and where they live, right? Quite straightforward. Because of the ambiguous or possible incorrect table naming, the potential misuse of customer ID versus customer unique ID, and lack of deduplication or edge case handling, the submission cannot be considered fully correct and complete per the rubric. The score should be false. All right, I guess. In our case, we wanted to use customer ID, but of course there is also a customer unique ID. This is something that the LLM or the judge does not quite know, but this is something that we provided in the prompt, in our version, where we explicitly mentioned the model to not use the unique ID. So it's followed it, and the answer is right for me, right to me. But of course, the judge marked us wrong. But this is something, again, we have to take a call, right? It just highlights the mistakes. In this case, it's fine for me, but of course you can go over some of the other runs. We can clearly see that the complex logic ones have failed consistently. We can take a look and see what areas have gone wrong. Now of course we never sort of tested our versions of the various iterations that we have built. It's mostly been just to optimize the obvious drawbacks. I think this is a good benchmark for us to evaluate our version 5 itself and see what where are the other mistakes in terms of providing the SQL code. Let's look at this. It says, because of the join induced duplication problem that produces a biased average review score, the query does not fully meet correctness requirements. Yeah, I think it refers to this join here. Ideally we want all the joins to be left join, and yeah. And interestingly, this is the same question that we have been sort of testing in the V5 video. We did get a right answer back then, but of course seems like it's left it here. And I'm sure a couple of, something that we have noticed consistently is the mistake in terms of joins, right? So maybe this is something that's useful for us, that's insightful. We should probably go back to the model, especially the final SQL query generation, where we want to highlight or not strictly specify that we want the kind of joins to be always left join, so it avoids any nulls or duplication and so on. But yeah, I think that's about for the kind of truth questions, test questions, and building that kind of ground truth data sets. Moving forward, we can of course work on optimizing these questions, maybe bring in different complex ones, but nonetheless this forms like a base for us to validate our questions whenever we make any changes in the app. um, right now, of course, the aim for us is to pass all the questions, or at least majority of them, uh, because looks like the existing model itself is not quite strong, especially in the complex ones. It's making a lot of mistakes. Yeah, so that's like the next direction, I believe. But of course, we'll see uh, how it goes. But if you watched the video till here, thanks a lot. I've received a good engagement with these videos of the project, and yeah, that's pretty much for the video. Thank you, and I'll come back with another video with probably another version of the app, and let's see. Thank you.